What are open-loop and closed-loop control systems in engineering? Imagine trying to keep a car at a steady speed. You press the gas pedal and hope the car maintains that speed. Now, think about how that compares to a cruise control system. One is simple, the other smart. That's what control systems are all about in engineering. They help machines and devices work just right, no matter what happens around them. In electrical engineering, control systems manage how devices behave by changing inputs based on what they need to do. The two main types are open-loop and closed-loop systems. An open-loop control system works without checking what's happening after it acts. It just follows a set of instructions. For example, a basic electric toaster heats bread for a fixed time. It doesn't check if the toast is golden or burnt. It just runs for that time, no matter what. Because it doesn't look at the output, it can't fix mistakes or adjust if something changes. These systems are simple, quick, and cheaper. They work best when conditions stay the same and external factors don't affect the process much. On the other hand, a closed-loop control system keeps an eye on what's happening and adjusts as needed. It uses sensors to measure the output, like a thermostat checking room temperature. If the room gets too cold, the system turns on the heater. If it gets too hot, it turns it off. This feedback helps the system stay exactly where it should be. These systems are more complex and cost more because they need sensors, controllers, and actuators. But they are also more accurate and reliable, especially when conditions change. For example, in motor speed control, an open-loop system might just give a fixed voltage to the motor. A closed-loop system uses a device called a tachometer to measure how fast the motor is spinning. If the speed drops because of extra load, the system increases the voltage to keep it steady. In signal processing and control systems, sensors gather data about the output, controllers process the error between the desired and actual output, and actuators make adjustments. This setup helps machines respond to changes quickly and stay on target. To sum up, open-loop systems operate without feedback, following fixed instructions. They are simple but can't correct errors. Closed-loop systems use feedback to compare actual output with the goal and make adjustments. This makes them more precise and stable, especially in changing environments. These ideas form the foundation for designing devices and processes that work well under different conditions.